Hi, welcome to lessons 9.2 to 9.4, combining two functions, arithmetic operations. The goal of today's lesson is to represent the sums and differences and products and quotients of two functions graphically and algebraically and determine their properties. The reason why we want to do this is to identify and analyze and then be able to simplify combinations of a variety of functions. Just like in the last lesson, we were exploring characteristics of new functions created by combining functions in order to be adept at working with combinations of functions. When combining two functions, the operation that we apply to the functions is only applied to the y values, and the domain of the resulting function is going to be the common portion or the intersection of the domains of the two original functions. So here in this first example, we're given sets of coordinates of two functions, and what we want to do is we want to find f plus g of x, f minus g of x, g minus f of x, f times g of x, and f divided by g of x. But what we first have to do is we have to identify the common domain first of all, because we can't add or subtract or multiply or divide y values if the two x coordinates are not the same. Okay, so first of all we want to go through these ordered pairs and identify which have the common x coordinates, and then those are the only points we're going to be able to use. Okay, so take a look at those, and then what I should suggest you do is circle the ordered pairs that have the same x coordinate. Okay, so we see that here the -8 is the same, so we use that point. And then I'll scan across here and I see that there's no -5, no -3 here. There's -1s that are common, the x coordinates, zeros, 4 also is common here. There's no 6 up here, 7 is common for the x coordinate. And there's no 10 down here, and there's no 12 up here, so those are the points that we're going to be using. So the x values are -8, -1, 0, 4, and 7. Okay, so now what we're going to do is, for all these operations, the sum, the differences, the products, and the quotient, take the y coordinates of those points that we've circled and apply these operations. Okay, I'll give you a couple minutes to work on that and then come back and check that you have all the values correct. Okay, pause the video now please. Okay, so now just check to make sure that you have all the correct values. The sums are going to be the same whether it's going to be g plus f or f plus g. The one thing that's going to be different will be the differences. As we can see that g minus f is the negative of f minus g. The products will be the same, and of course the the quotients could also be different. So g divided by f most likely would be different than f divided by g. Okay, so now we have a couple of the functions. We've got f of x is 3x plus 1, and g of x is x squared minus 2. We want to use these two graphs that are graphed for you there below and sketch f plus g of x and f minus g of x. So we'll sketch f plus g of x on this left-hand graph and the f minus g of x here on the right-hand graph. Okay, so what I'd like you to do is basically you want to line up the points where the x coordinates are going to be the same. So obviously we'll find points that are easy to use. So just scroll up a little bit there. So I usually use a ruler just to verify that I'm using the correct points. So we use this point here. I think it's right there. So that would be -3 and 7. And this point, -3 and -8. And then, so I'm only using these points that are convenient to use. Like, we could obviously use points in between x equals -2 and x equals -3. However, they're a lot more difficult to see what y values they are. So I just go along here and identify the points I'll be using, just to make sure that we're using the same points for the points for the same x coordinate. And this also should illustrate that the domain has to be the same, because if we were to look way over here, we can see the graph of g of x when x is +3, but we can't see the y value, or the y coordinate of the graph of f of x when x equals 3. So because the domains aren't intersecting there, then we can't actually form another point with that x coordinate. Okay, so that could verify, hopefully for you, why we need the x coordinates to be the same when we're combining functions. Okay, so now we'll just take those y values and we'll combine, or we'll add those y values together, because we're doing the sum here of f plus g of x. So we've got 7 plus -8, which is -1. So I'll just put an x there, just to make it different than the points. And then I've got +2 and -5, so that gives us -3. And then there's -1 and -2, which also gives -3. 1 and -2 will give us -1. And then we've got 4 and -1, which will give us 3. And then here is 7 and 2, which will give us 9, which is above the scale here. It's above the top of the graph, the top of the grid there. So, as you can kind of see there, that resembles a quadratic, and I believe the turning point of the quadratic is between these two points here. And so I'm just going to do a little sketch. I'm just going to estimate where it'll be. Now we can't really know exactly where that's going to go. Well, I guess we can guess, but we'll just sketch this through. Okay, so this is the graph of f plus g of x. Okay, now what I'd like you to do is do a similar thing with f minus g of x. Please, so pause the video and draw the graph of f minus g of x. Okay, so again, I'll identify the points I'm going to be using. And quite coincidentally, they're the same points as we use on the first one, because they're the same functions. And now f minus g, so the quadratic is g and the line is f. So we'll be doing f minus g. So here's -8 minus 7. Well, that gives us -15. There's no way we can fit that on the grid here, so we're just going to have to pretend that it's way down there somewhere. Then we've got -5 minus 2, which gives us -7. Okay, so we can do that. There's -7 there. Then we've got 1 minus -2, So 1 minus negative 2 will give us 3. And then here is 4 minus negative 1, which gives us 5. Then we've got 7 minus 2, which is 5. And we would find, if we go one more point, that the next point would probably be right about here, as you can kind of see with this is forming a quadratic. And so it's just going to go like this. More or less like that. Okay, so hopefully you got something similar to that. And I know this isn't a really great diagram of the quadratic, but I am not an artiste. Okay, so the next thing we have to do now is for both of these parts, we need to determine an expression for each of these functions for part A, so f plus g of x and f minus g of x, and here is f minus g of x. And in order to get the expression, we're just going to add these together. So